Now let us understand what is Carpet Theorem, and before that let us understand the kind of question which appeared in under Carpet Theorem, right? So here the question is that the triangle, square ABCD is a square, and there are points M and N on AB and BC respectively, and the lines are joined as you can see, and these numbers are nothing but the area of this triangle APM. This is the area, 20 is the area of the quadrilateral MQNB, and 16 is the area of the triangle CRN, right? So now the question is asking about finding the area of quadrilateral PQRD, right? So this is our objective for this question, that we have to find the area of the quadrilateral PQRD, and nothing else is given. The only thing is given is that ABCD is a square, and these are the three areas, right? Now we'll approach and solve this question by Carpet Theorem, and you will see that we can solve it within 15 seconds. But before that, let us understand what Carpet Theorem means. So Carpet Theorem is effectively is more a common sense, I would say. So suppose if I take an example, say there is a floor ABCD, right? And the floor is of, let's say, 10 feet by 6 feet, right? And you went to the market to get, or you want to get this floor to be covered with the carpet entirely. You went to the market and you want to find that a single carpet of dimension 10 feet by 6 feet should be available. But unfortunately, of such dimension carpet is not available. So what you decided is that if there is a sort of carpets which you can use to cover the rectangle ABCD. So in the market, the carpets are available of the size 6 feet by 2 feet. So definitely you will purchase 5 of such kind, right, to cover the rectangular floor. So you came to the house and you just covered it. So you can just see these are the strips which are the carpets, right? So if I just fill them with a color, so these are the carpets which you have filled. Now you didn't fix them appropriately, and what happened is that somebody came inside this floor and he dislodges this particular carpet, and this carpet after dislodging looks like this. So this dislodged carpet will be something like this, say. Fine. Now what has happened here? As you can see, there are some areas which have been overlapped, right? So let me use a different color to show you that which area is overlapped. So this much portion of the carpet is overlapped, and there are certain areas which now looks vacant. Not this, but this one, and definitely there is some point here as well. Fine. So what can we deduce from this? We can deduce one thing by just common sense, is that this vacant area must be equal to the area which has been overlapped, right? That's the simple concept, because the complete the total area of all the 5 carpets together is the area of ABCD, right? But it has been dislodged and some area has been overlapped. So the area which has been overlapped must be equal to area which has been vacant. This is the simple concept of Carpet Theorem. Fine. Now we'll use this concept to solve the question which we took. So let's go back to that question. Now the question was to find the area of the triangle, area of the quadrilateral PQRD, right? Now one thing very obvious is that if I take any say rectangle or a square, suppose I'm taking a square and it has some area, and if I want to find the area of this particular triangle, right? So this is the triangle. So it has been divided into 2 parts, right? I can say that the area of each of these triangle is half the area of the square, right? And at the same time, if I had taken or drawn the triangle inside this square differently, for example, if I draw the triangle like this, then we can say that the area of this triangle is again half the area of this rectangle or square. Fine. So we'll use this simple logic in this question. So now let's come back to this question. Now let us observe the triangle AND. So if I observe triangle AND and the area of it, then I can say that this is half the area of square. Similarly, area of triangle say DMC will again be half the area of the square. Correct? So if I add these two triangles, then definitely this will be equal to the area of the square completely. Fine. Now suppose these are the size of carpet. The triangles are the size of carpet and you want to fit it into the square and you have fit it in like this. So I can say from the logic that this portion, that is this portion plus this portion plus this portion, combinedly will be the area, half the area of the square, right? And similarly, if I combine this portion as well as this portion, then these will be the area which will be covered with the carpet, and rest of the area, the value of which are given like 12, 20 and 16 will be uncovered. Now here again I can observe that there is some portion which is overlapped like this. So this is the portion which has been overlapped. Had we cut this triangle into a small pieces and try to fit all those pieces into the square, then the without overlapping, then entire area of the carpet will cover the square. But here, because of such arrangements, some portion is overlapping, and that's why there are portion in the square which is denoted in the white portion are left out. So easily with that concept I can say that the area of this particular quadrilateral is nothing but equal to the area of the places which is vacant or is not covered under the carpet. So straight away the answer will be 12 plus 20 plus 16, which comes out to be 48. So this is the answer, and this is how we actually apply the carpet theorem. Correct? Now let us take another example. So let us take a carpet theorem in a circle also, right? So suppose this is a larger circle and all these four smaller circles have the radius half the larger circle. Now you can see that the area of larger circle will be equal to 4 times the area of smaller circle. Fine. You can see that if the area of the larger circle say C is capital R, then the area of each of the smaller circle will be R by 2, or in fact the radius will be R by 2. So the area of the larger circle will be pi into R square, and that can be written as 4 into area of each of the smaller circle. Correct? Now suppose the circle, the larger circle is the floor, and you came up with this smaller circle as a carpet and you try to fit it like this. So here again you can see that there are a lot of space which has been overlapped, right? So this and this portion has been overlapped, and the vacant space is this and this. So we can say that the area of green portion must be equal to area of blue portion according to the carpet theorem, right? So this was all about the carpet theorem.